Hello students, welcome back to CLARI Concepts, Unleashing Conceptual Learning. For more lectures of such kind of topics, you need to log in to clariconcepts.com. So today we will continue again with the series of Newton's law of viscosity's numerical portion. So we have today, the fifth numerical of this particular topic, that is the space between two square parallel plates. So you have been given two square parallel plates is filled with the oil. Each side of the plate is 60 centimeters. So you have been given plate. So I'll just put the plate, a square plate, and we know that each of the side is how much? 60 centimeter on both the ends. 60 centimeter, 60 centimeter, right? This is the top view. The thickness of the oil film is 12.5 mm. So if I talk from the side view, if you see, this both the plates look like this. From the side, this is the thickness of the plate, and the plates are placed like this, right? So you have two plates. From top view, when you see, you look it like this. So this is the square, 60 centimeter by 60 centimeter, right? But from the side view, this plate looks like this, two plates, isn't it? Now the oil is filled over here on between both the plates, oil. Each side is this. The thickness of the oil film is 12.5 mm. So this thickness is given to you as 12.5 millimeter. The upper plate, which moves at 2.5 meter per second, requires a force of 98.1 Newton to maintain this speed. So this plate by default is fixed. The upper plate moves at 2.5 meter per second, and when it moves at this velocity, the requirement of force is 98.1 Newton. So force required is 98.1 newtons. Determine the dynamic viscosity of the oil in poise and also the kinematic viscosity of the oil in Stokes if the specific gravity of oil is given to you as 0.95. So let us first see what is the given data to us. Just write down the given data. The first data given to us is the side of the plate is 60 centimeter, right? So basically this will be required to calculate the area. So if I want to see the area, each side is 60 centimeter, right? So can I say this is 0.6 meter by 0.6 meter? So if you want to calculate area, this is 0.6 meter because you divide it by 100 to convert centimeter into meter. This is also 0.6 meter. So 0.6 into 0.6, that is 0.36 meter square area, right? Then thickness of the oil film, that is L, 12.5 millimeter, which again will be equals to, you divide it by 1000, you will get 0.0125 meter. You just check it like this, okay, 3 decimal backward. The upper plate moves at velocity 2.5 meter per second, requires a force of 98.1 Newton, so F is 98.1 Newton. Then the specific gravity of oil is given to you as G as 0.95. You are supposed to find out mu, that is question mark, and also kinematic viscosity question mark. So let us start solving this. So firstly, I know that as per the Newton's law of viscosity, mu equals tau equals to mu du by dy, isn't it? Now again, assuming the linear velocity profile, du by dy can be replaced as v by L. Very simple, right? Now for tau, we can say tau is equals to resistive force divided by area equals to mu v by L. Now put all the values. Value of force given to you is 98.1, area given to you is 0.36, mu you don't know, v velocity is 2.5 meter per second, length of the oil film, thickness of the oil film is 0.0125. So if you want to see mu is equals to 98.1 into this, 98.1 into 0.0125, and then 0.36 in the denominator, and take this with 0.36, sorry. So the value of mu you will get is equals to 98.1 into 0.0125 divided by 0.36 divided by 2.5. That is coming out to be 1.3625, and the unit will be Pascal second or Newton second per meter square, which is the SI unit, right? Now if you want, because they have asked you the value of mu in poise, so when you want to convert the value from SI unit into poise, you multiply the value by 10. So you multiply this value by 10 and you will get this in poise. Right, so mu will be equals to 13.625 poise, which is your first answer. Answer 1. Now, your second answer is you also require to find the value of kinematic viscosity. So, kinematic viscosity is defined as the ratio of mu divided by density. But you don't know what is density of the oil. But you have been given the specific gravity of the oil, right? So, if specific gravity is given to you, you can easily find density by multiplying that with density of water. So, Sg, density of oil will be equals to Sg of oil into the density of water, which is 1000 kg per meter cube. So, you will get kinematic viscosity as what is value of mu. Now, again, here you need to put the value in SI unit to get this in SI unit, because you have substitute all the values in SI unit, right? So, put the value of mu in of this 1.3625. 1.3625. Sg given to you specific gravity is 0.95 and this is 1000. So, divided by 0.95 divided by 1000, I will get, I am just writing the answer over here. Kinematic viscosity nu is equals to 1.4342 into 10 raised to minus 3 meter square per second is the SI unit. But you have been asked to find out in stocks. When you want to convert a value from meter square per second into stocks, you have to multiply by the multiplying factor of 10,000, if you remember this, because we have understood that in the theoretical aspect. So, if you have any doubt in this, you can refer the previous lectures where I have explained you the theory behind this conversion. So, this is 1.4342 into 10 raised to minus 3 into 10 raised to 4 centimeter square per second बोल दो या फिर आप बोल दो Stokes, they are both the same. So, this mu 10 raised to minus 3 with cancel with this 110 will remain, 110 you multiply over here, you will get 14.342 stocks. 14.342 stocks. Let me check the answers. Yes, the answers are absolutely correct. So, this is the answer number 2 that you were looking for. Answer number 2. I hope you got the answers right. Let us move ahead with another example. Determine the viscosity of liquid having the kinematic viscosity 6 stocks and specific gravity 1.9. Very simple. See, given data, what is given to you? You have been given the kinematic viscosity in stocks, right? 6 stocks and specific gravity 1.9. Now, you convert this into meter square per second. How do you do? From stocks, that is CGS, to SI, you always divide by a factor of 10 to the power 4. So, 6 divided by 10 to the power 4, this will be meter square per second, and this is anyway unitless. They asked you to find out the viscosity of the liquid. Viscosity meaning dynamic viscosity. They are talking about the dynamic viscosity, right? So, dynamic viscosity mu. I know nu is equals to mu by rho. So, mu will be equals to nu into density. Yes. Now, nu I know this is 6 divided by 10 to the power 4. What is density? Density is referred as specific gravity into 1000, which means density of water, right? So, if any specific gravity is given to you for any liquid, you multiply that with the density of water to get the density of that particular liquid. So, I will get 6 divided by 10 to the power 4, Sg is 1.9 into 1000. So, the answer that I will get is 6 into 1.9 divided by, multiply by 1000 divided by 10,000. Simple. This is 1.14. 1.14 Pascal seconds. Right? Clear? Let me check the answer. Yes, 1.14 Pascal seconds. This is the correct answer. So, this is the answer. I hope you are understanding this, right? Let us move on to the next example. Okay. A fluid has absolute viscosity of 0.048 Pascal second and a specific gravity of 0.913. For the flow of such a fluid over a flat solid surface, the velocity in meters per second at a point y meters away from the surface is given by u equals to 30y minus 200y square. Now see, there is no more two plates. You have been given a solid surface. The flow is happening over a solid surface. So let's say this is a solid surface given to you. This is a fluid flow happening over it. And they said that the velocity profile in terms of u meter per second and y distance from the bottom plate is 30y minus 200y square. Now here you cannot assume the linear profile because profile is already given to you. Okay. Now what they are asking, calculate the shear stresses at the solid boundary at a point 25 mm, 50 mm and 75 mm away from the boundary surface. See what they are asking. They are asking to calculate the shear stress at the bottommost layer, that means solid boundary. They are asking to calculate the shear stress at a distance of 25 mm from the solid boundary, that means at this layer. They are also asking to calculate the shear stress at a layer of 50 mm and a layer of 75 mm. Simple. Clear? So before moving to that, let us come back to given data. Given data, very simple. Viscosity is given to me, which is 0.048 Pascal second. Already this is in SI unit. Specific gravity is given to me 0.913. Then I have been given the distribution of velocity u equals to 30y minus 200y square. Calculate the shear stress. I need to calculate shear stress at different points at y equals to 0, at y equals to 25 mm, then 50 mm and 75 mm. So all of these are question marks, right? So let us start solving it. I know shear stress is equals to mu du by dy, isn't it? Therefore, shear stress should be equals to mu du by dy. I need to first calculate what is du by dy. So firstly, I know u, which is 30y minus 200y square. Now calculate the differentiation of this u with respect to y. So I will differentiate this equation with respect to y on both these sides. So du by dy will be equals to, the derivative of 30y is just 30 and the derivative of y is just 1 minus 200 as it is. What is the differentiation of y square? It is 2y. I hope you are aware about differentiation. So this du by dy will be 30 minus 200 into 2, that is 400 y. Now you put this value over here. So this is tau equals to mu 30 minus 400 y. Very simple. Now you see, here in this case, du by dy has also the variable called y, which means at different values of y, du by dy will be different, and which again means that at different value of y, tau is also going to be different, right? So I will say tau will be equals to mu into 30 minus 400 y. So let me take the next slide. Tau equals to 30 tau equals to mu into 30 minus 400 y. So first question was tau at y equals to 0 mm. So simply put value of y as 0 meters. What is value of mu? Mu is given to you as 0.048. So 0.048 into 30 minus 400 into 0. This will be directly 0. So I just want to calculate 0.048 into 30. 0.048 into 30. 1.44 pascals. This is answer number 1. Right? Second, tau at y equals to 25 mm. Now see, again I am saying when you substitute the value of y, you always need to put it in terms of meters because it is an SI unit, right? So mu is 0.048 into 30 minus 400. What is y? 25 mm. So meter of that will be 0.025. So I'll calculate 400 into 0.025. Okay, so 30 minus answer into 0.048. This will be 0.96 Pascal. Answer number 2. Right? Then third, tau at y equals to 50 mm. you will calculate 0.048 into 30 minus 400. You will substitute the value of y in terms of meters. So 50 mm will be 0.05 meters. So this will be 400 into 0.05, 30 minus answer into 0.048. This will be 0.48 pascals. Right, answer number 3. And finally, number 4, tau at y equals to 75 mm, you will get 0.048 into 30 minus, I would say 400 into y. So 400 into what is y? 0.075. So I will put this value 0.075. 30 minus answer. So this answer is going to be 0 Pascal. So this is answer number 4. Now you check. So what did you found out? You found out the value of tau at all the layers. Tau at 0, y equal to 0, y equal to 0.25, sorry 25 mm, 50 mm and 75 mm, right? And all these values are the answer of the same. This is at 0 mm, 25 mm, 50 mm and the 75 mm. So I hope you understood the theory and how to solve the numerical for this particular topic. See you soon in the next class. Thank you so much.